Welcome to yet another exciting session where we're going to talk about mathematics, that wonderful subject called mathematics. Today we're going to learn about fractions and decimals. Our topic today is fractions and decimals. Now, in this lesson, we're going to cover three lines of thought. Number one, we'll be identifying the greatness of a fraction, which is talking about which of the fraction is greater, comparing two fractions or comparing multiple fractions to find out which is greater and which is smaller. Number two, we'll be talking about arranging fractions in ascending and descending order. And finally, number three, we'll be talking about the conversion of decimals to fractions and also fractions to decimals. Shall we begin? Now, when we talk about fractions, one of the things that comes to our mind is division. Dividing two possibilities, one item with another item. Now we're talking about how to identify whether a fraction is a greater or a smaller fraction. How to identify it. We must first note in the first instance that if a fraction have the same denominator but different numerators, that particular fraction is greater. What that means is that if you have set of data, and let's say you have 4 over 10 and you have 3 over 10, the same denominators, and we know that denominator is everybody at the lower end of a fraction, the lower side of a fraction. Those are called the denominators, while the upper side are called the numerators. So in this case, we're having 10 and 10, which are the denominators, to be the same. But their numerators, 4 and 3, are two different numbers. And what that logic in number one is telling us is that, logically speaking, the one with the greater number, which is 4, the greater digit, which is 4, tends to make up the greater fraction. So it means that 4 over 10 here is greater than 3 over 10. Now, in a different case scenario, what if the numerators are the same? Which means the upper sides are the same. Let's say 2 over 5 and 2 over 7. The upper sides are the same, but the denominators, which is the lower sides, are different. You must understand that that fraction which has the lower or the smaller denominator is greater. In this case, if you look at the numerators, both the same, but the denominators are different. What our logic in number 2 is telling us is that when you have 5 and 7 given to you, 5 is a lesser number there or the smaller number there. 5 makes up the fraction that has 5 in it, makes up the higher or the greater fraction. It then means 2 over 5 is greater than 2 over 7 in this scenario. Let's see more about this with examples. Now, if you look at your screen, you'll see an example. They say which is greater between 1 over 8 and 4 over 8. You must understand that when you look at a particular comparison or you look at a particular structure in a fraction, if you look at the lower end, and you find out that the eighths are equal or the same. The upper side, which is the numerator, if they have different numbers, comparatively, you look at the higher number. That number which is greater is the one that makes up the greater fraction. In this scenario, they are 1 over 8 and 4 over 8. If you compare the 1 and the 4, we know they both have 8 as denominators. When you compare the 1 and the 4, you find out that 4 is greater than 1. Thus, 4 over 8 is greater than 1 over 8. In that same line of thought, if you look at the example 2, you find out that there is a different scenario there. There is 1 over 6 and there is 1 over 7. In this case, the numerators are the same, 1, but the denominators are different. 6 and 7. And in our case, when we look at the case study, when we're looking at the outline there, we were told that when the numerators are the same and denominators are different, the denominator amongst the different number, the one that has the lower number or the smaller number, is the greater of the fraction, or makes up the greater of the fraction. In this case, if you look at it very well, 6 is less than 7. Thus, 1 over 6 is greater than 1 over 7. Take this idea into whatever you want to do, and you'll find out that you will get it right most of the time. You could take the long possible road of using a long division or a short division to find out which is greater or which is smaller. But if you use this instance or this logical application, this reasoning will take you quicker to the solution than any possible manipulation of mathematical logics can take you. Now let's see the next part of this whole talk. Now we are looking at arranging of fractions in ascending and descending order. Now you are given series of fractionable sums. You're given 5 over 6 as you can see on your screen, and you're given 8 over 9. You're also given 2 over 3. And you're asked to arrange these fractions in if they are in ascending order, rather from ascending order, which means from the lowest to the highest. Ascending is going from the lowest to the highest. It's like an aeroplane taking off from the tarmac, from the grid. The aeroplane goes and is about to take off. So he's climbing up. But when the aeroplane reaches the height and is about to land, there is a descending order. So the aeroplane starts coming down and it descends. In this case, when it's coming this way, this is descending. When it's going upward, this is ascending. So we are talking about going from the lowest point to the highest point, ascending to this, from descending order to from the lower order to the highest order. Now we are asking which is the lowest and which is the highest. So in this instance, there are 2 possible ways you could do it. The first instance is what you're seeing on the screen. The second instance is what I will show you on the board. The second instance is using of the long division method. But let's see the idea of using the LCM method. The LCM method talks about taking the 3 denominators. The 3 denominators there are 6, 9, and 3. 6, 9, and 3. What you do now, you take the 3 of them and you find their LCM. So we have 6, 9, 3. Looking for their LCM. We know that on the first instance, in LCM, you take, you use the number which is least first, the least possible number. Thus, lowest common multiple. The least possible number is 2. You use 2, 2 can go into 6, but cannot go into 9, cannot go into 3. So you keep back the 9, you keep back the 3, and 2 into 6 will give you 3. Now you see 2 can no longer go, you find the next possible number, the next possible lower number that can go through. You find this 3. 3 can go into everybody here. 3 into 3, 1, into 9, 3, into 3, 1. And finally, you go use 3 again. 3 can go into everybody here to be 1, 1, 1. And you find that your lowest, your LCM is 2 times 3 times 3, which will give you 18. As you can see on your screen. But what you use this 18 for, the revealing thing is what you're going to use the 18 for. And that's where the lowest common multiple, the LCM method, comes into play. Now, listen, look at the screen and read it carefully. You understand what you're going to do. It says, now to make the fraction as like fractions, divide the LCM by the denominator of the fractions, then multiply both the numerator and the denominator of fraction with the number gotten after dividing LCM. What that means is, let's take it one after the other. Each of the fraction use their denominators. Use the LCM gotten. For example, you use 18, you use 6, because The 18 can go into all three of them. All three fractionable numbers can work with 18. The denominators especially. The denominators, which is 9, 6, and 3, they can all work with 18 very well. So you use 18 to divide 6 the first instance, which is 18 divided by 6. As you can see on your screen, you find out is 3. Now, the next step is to use the 3 to multiply with both the numerator of the same fraction, the same 5 over 6. The numerator 5 multiplied by 3, the denominator 6 multiplied by 3. If you do that, you will find out that you get 15. 5 times 3 is 15, and then 3 times 6 is 18. You get 15 over 18. Similarly, when you do the same math for use 9 to divide, or rather 18 divided by 9, use 9 to divide 18, and you get 2. Multiply 8 by 2, you get 16. Multiply 9 by 2, you get 18. For the last case scenario, you use 3 to divide 18, you get 6. 6 times 2 will give you 12. 6 times 3 will give you 18. Now you've gotten everybody you need. All the fractions are now in the mode of 15 over 18, 16 over 18, 12 over 18. Comparatively, when you're comparing all the number, you find out that you've gotten what we were saying initially, greatness of a fraction, the greatness of a fraction. But in this case, if you look carefully, all their denominators, what you're having now is this. Let me represent it for you. You're having 15 over 18, you're having 12 over 18, and then 16 over 18. If you look carefully, all their denominators are the same number. Our logic in the introduction comes into play when the denominators are the same. Numerators are looked upon. Different numbers in the numerators, find the greater number. The numerator with the greater number comes first. So it means your answer there will be in the likelihood of 16 over 18, 15 over 18, and 12 over 18. That's your answer. When you do comparatively, when you compare all the fractions and you find that 16 is greater than 15, 15 is greater than 12, and that's your final result. Now, going by reducing fraction to the lowest term, you can also reduce the fraction to the lowest term, but it will still come back to the same place where you came from. What it means is that you will come back to the same case of greater than, that is 8 over 9 is greater than 5 over 6 is greater than 2 over 3, or 2 over 3 is less than, you go from the reverse way. So you are going either the highest to the lowest or the lowest to the highest. Either way, it will give you is the same answer, is structured in the same way. The ascending order of the fraction now is using the smallest number. 2 over 3 now we find out to be the smaller number, which is the one that gives you 12 over 18. 5 over 6 the next, and then 8 over 9. You're going from the lowest to the highest. Let's see the next point. Okay, we have an activity here. You can quickly copy the activity. They are giving a set of fractions, and they're asking find all in ascending, not descending. You must understand. Again, we say ascending is going upward from lower to higher. Why descending is going downward from higher to lower. Understand the difference. So in your case number 1, 13 over 22, 18 over 22, 10 over 22, 3 over 22. To highlight it for you, you will notice one thing that is prevalent there. Something is just prevalent. We've made it so easy for you, so you can do it something is working with the denominator, so I'll give you the time to think about it. Second case scenario, 9 over 42, 16 over 42, 33 over 42, and 39 over 42. Please do that and get acquainted. Look for more questions to answer from the net, and try and get yourself acquainted with all that has to do with the ascending and descending order of fractions. Now, to my interest today. Okay, before I really enter this part, I earlier on said I will use a different method to find this. And that method is also linked to what we have on the board, converting decimals to fractions, and then from fractions to decimal. Let me first of all use that case that I spoke about earlier on, how to find it. Now we use the 1 over 8 and 4 over 8 to describe my point on this. Or no, let me use the one we just finished with. 2 over 3, 8 over 9, and 5 over 6. 2 over 3, 8 over 9, and 5 over 6. They're asking which is greater and which is smaller, from the smallest to the greatest. Now let's see. Using long division. So in this case, you'll be learning long division along with this. And that's good. Killing two birds with one stone. Now we are doing long division here. We have our 3. 2 into 3 will give us 1. 1 times 2 is 2. If you remember your long division very well, you know that you have to subtract the 3 from the 2 and you get 1. 2 into 1 is impossible. You put a decimal point and you add a 0. 2 into 10 is 5. 5 times 2 is 10. And thus when you do this, you have your quotient, and your remainder is 0. 1.5 for 2 over 3. The next one is 8 over 9. So we're using the 9 to divide the 8. Or rather, sorry please, I used the wrong illustration please. We are using the 3 to divide the 2, not the 2 to divide the 3. Sorry. The denominator is 1 dividing. So this is 0. Then you add a 0 here. 3 into 20 is 18. It's 6 rather. 6 times this is 18. That's the closest number to 20. Then you minus through. And you have 2. 2 into 3 into 2 again cannot go, so you add this. I always add a tiny 0 just to make you understand that there's a minute 0 there, and you add another 0 to make it 20. 3 into 20, the exact same thing. 6 plus a 0 will give you 6 here again. And if you find that this is what we call a repetitive fraction or recurrent decimal. A repetitive fraction or recurrent decimal. The decimal will keep on going as long as you are going till life ends, till Jesus Christ comes, if you believe in him. This 20 will keep on appearing, the 18 will keep on appearing, and it will never change. And you keep having 6, 6, 6, 6, 6, 6 till infinity. So we can end there, and we see that our answer for this one is 0.66. So we have the first fraction, 0.66. And then we take the next one, 9 dividing 8. 9 dividing 8. Again, 9 is bigger than 8, so you cannot divide. So you add a 0 and a decimal point, and you add a 0 to make it 80. 9 into 8, into 80 rather, we go 8 times. Because the next number that is closest to, under the 9 multiples of 9, the next number, the one that is closest to is 9 times 8, which will give us 72. After 72 will be 81. 81 is greater than 80. So we put the, rather 8 here. 8 times this is 72. And when you subtract, you find out that you get 8. And then you do this again, and the exact same thing will repeat itself, and you get the exact same number. And as in the case of, as in our first case, you keep having a recurring decimal. 888, 0.8888, and it's going ahead. Decimal number is recurring, and also it will be the same fraction, repetitive fraction. So this, we can just take our 0.88 to be the next one here. Then looking at the last but not the least, we have 6 divide 5. Now 6, the same thing plays here, 6 into 5, 0 points. Now 6 dividing 50, 6 is going into 50. How many times will it separate? How many times will it work? My head tells me it's 8 times. 8 times 6 is 48. 8 times 6 is 48. 50 minus 48 will give us 2. Into this will not go. You put a little 0 and put a bigger 0 here. 6 into 20, the closest is 18, which is 3. 3 times 6 will give us 18. And you find out that you are in that loop again. You are in the loop where things keeps recurring. And you have things that something that have to do with 0.8333 gone. So let's just take the 0.833. Now, in this case, we've seen that we have the 3 decimal. We've converted the fractions to decimal. 3 different decimals. From the fractions, we've gotten the decimals. This is not to guide you very well. Also to make, if you want to use this strategy, also fine by me. The way to find which is greater. Now, if you look very well, 0.66 is the least here. 0.833 is less than 0.88. Even if it's by the smallest of margin, a greater number is a greater number. Even if this one was 0.887 and this one was 0.88, the one with the higher number by 0.01 is the greater number. That 0.01 in the logical sense of mathematics can make a whole lot of difference. So you structure it this way: 0.66, 0.833, and 0.88. In our fraction, it will be 2 over 3, 5 over 6, and then 8 over 9. So just another way by which you can do your fraction or convert your fraction to decimal, and vice versa. Yes, we can also teach you how to do the conversion from decimals to fraction, as you can see on your screen right now. We can express a decimal number as a fraction by keeping the given number. I will expand on that later. By keeping the given number as the numerator without a decimal point and writing 1 in the denominator, followed by a series of 0, as many zeros as we counted, as we're going to be seeing right now. Say you have a number like this. Sorry, let me erase this. Okay, let me leave our good friends here so we can use it to convert. Let's use it as our case study. So you have a series of numbers like this: 0.66 and 0.88 and 0.833. First things first, let me just give it what they are saying there, by keeping the given number. That word by keeping the given number means by keeping those numbers that are called significant figures. In mathematics, that's what we call significant figures. Any number that is 1 and above, greater than 0, is a significant figure. 0 is a void number. I call it a void number or insignificant number, because except it's in between 2 significant figures. What I mean is, when you have 602, that's 602. Now the 0 becomes something tangible. It's holding the place of tens in our place value. So it's tangible. But when it's not close to anybody, is working with decimal points, is somewhere else, is holding a whole number on its own, it cannot hold water. So it's kind of a void number. Hence why anybody that multiplies with 0 becomes 0, because 0 is void, and void is like nothing, nothingness. It kind of shadow you and eat you up. In this case, we will count. They said in the line they says counting as many times you move in your decimal place. So what it means is that our significant numbers here start with 66. So keep the 66, put your division sign, put 1, you must always put 1, then count your decimal point out. We want to erase the decimal point, we want to throw it away. If you look here, we can count 1, 2, we've eliminated the decimal points. Thus, we counted twice. Put as many zeros as you counted. How many times did you count? 2 times. Add 2 zeros. 1, 2. This is the fraction of this. Of course, by the time you reduce to the lowest, you will find out that you will arrive at a particular given answer. Now, in this second case scenario, you have 0.88. Keep the 88 all over. Count, if you see, you count 2 times again. Put back your 1, count 0, 0. You have 88 over 100. You can reduce to the lowest term. My work is to show you how you convert from decimal to fraction. Next one, you have, I love this one because this one is multiple or it's beyond 2 decimal places. These are 3 decimal or 3 figures after the decimal point. We're having, so we can make it 833 all over. You count 1, 2, 3. You put back your 1, you count your 3 zeros. 1, 2, 3. And you find out that you got 833 over 1,000. Now, in that case scenario, that's how you convert from decimals to fractions. You're going to see some other examples here. So in this case, they are asking us to do 124 divided by 6. Oh, sorry, 124.6. You see, convert 124.6 to decimal, to fraction rather, from decimal, because it's, bless me, the presence of the decimal point makes it a decimal number. So we're moving from decimal number to fraction number. And when you're counting, remember, always count. When you are counting to get a fraction, you count from left to right. But when you are working with fractions, you're going to be seeing later, you work from right to left because you're bringing the decimal point inside. In the first case, you will see they moved slowly. They moved because we're moving inside. We moved 1 and we added a 0. We moved second one and we added another 0. And then we move, so your answer now right now is 1, because you're going to count 3 times to get the significant figures, is 1,246 over 1,000. Because you count 3 times to eliminate the decimal point. Thus, your numbers become 1,246 over 1,246 over 1,000. Now, convert, if they ask you convert 0.0035 into fraction in the simplest form, which when the word is used simplest form, take note of that word. You can see, or you might come across questions like that, or you will come across questions like this in your exams. When you're giving questions like this to the simplest form, when you convert, please endeavor and ensure to reduce to the lowest possible number, the lowest possible fractions rather. Don't just leave your answer as you will see here. Reduce to the possible, the lowest possible fraction. Now, if you look at your right hand side, you will see how it was solved and how the movement was. 0, you got 35 over, how many times did you move? You counted 1, 2, 3, 4 to eliminate the decimal point. And thus you put 1. You can see 1 that was already down. Then you add the 4 times you moved, 4 zeros, which signifies 4 times you moved the decimal points. And you get 10,000. So you have 35, which is a significant figure there, over 10,000. Friends, you have to reduce to the lowest possible form, or the simplest form, which means 5 can go into both of them. 5 into 35 is 7. 5 into 10,000 is 2,000. Nothing can go against. So 7 over 2,000 is the simplest form for that particular question. Note, when you're giving, in that case scenario we just used, in the example that was just given, or in the analogy we just made just now, the decimal number without the decimal point as numerator. In the denominator, write 1. Keep the numerator with the number that was given without the decimal point. Keep the number that we're given. The decimal number initially now makes up the number at the numerator. Under the at the denominator place, you put 1, followed by how many times you have moved or you've counted your decimal point out. If it's 4 times as we just did, put back your 4 zeros. I hope that is clear enough for us to understand. So we can move to the next point. Now you're given, you're told to convert a fraction having 10 in the denominator. Now, what I personally call questions that have to do with 1 and zeros as the denominator, I call them fine numbers. I call them fine numbers. Why? Or fine fractions rather, because those numbers, fine numbers actually, those numbers makes the fraction a bit easier, less stressful. And all of us will love less stress, right? I mean, imagine you're doing math and your head is about to blow off. You just want to do it so easy. So with the zeros, it's so simple. Now, the reverse is the case when you're doing for fraction or when you're converting fraction to decimal. Whenever you see something over 10 or 100 or 1000 in this case, it's so easy. For every zero you cancel, your decimal point is moving. So in this case, let me look over here and just do it quickly. In this case, this 0 will give us 83.3 over 100. I've eliminated one 0. I eliminate another 0, it will give us 8.33 over 10. Another 0 is gone. I eliminate the last 0, it will give us 0.833. And then we are back to our good friend here. Easy peasy. Lemon squeezy, as I said. Now you come here again, you divide this, and you get 8.8 over 10. Because you're working with 100 this time. 10 is remaining now, you remove the last 0 from the 10, and it becomes over 1, which you're making it a round up number, and it becomes 0.88. You're back to our good friend over here. In this case, you cancel one of the zeros, and this becomes 6.6 over 10. You cancel the next 0, it becomes 0.66 over 1. Anything over 1 is that same number. Thus, you've come back to our good friend over here. That's how you solve fine numbers. Of course, it's not going to always be a fine number like 10, 100, 1,000, hundreds of thousands, tens of thousands, and the rest. It's going to be a bit trickier. But you must understand that gradual process gets you to the destination. Now look at this second case. They said to convert a fraction having 100, which is what we just did on the board. In the denominator, we put the decimal point 2 places left. So you count twice to the left of the first digit of the numerator. So 7 over 100 now. Move the first 0 to the front and it becomes 0.7. Another 0 to the front, it becomes 0.07. 77 over 100 is easier. Just move it to the front of the two significant numbers and add the 0, and your decimal point is there, and you have 0.77. I'm sure that by what we've analyzed so far, it will be easier to shine a light on or shed more light on this without breaking much sweat. Now let's see the last part of this session. To convert, okay, we've already touched on this already. We've touched on this using long division. We've touched on this. So examples of this. Okay, now we are having a scenario where we're not having fine numbers. Let me just touch on this, shed more light on this before we finish this session. You're having an example where you have to work with numbers, or rather fractions that are not fine numbers, as I explained here: 10, 100, 1,000, and so on and so forth. The 0, 1 and zeros. What if you have case where you are working with 15 over 2, as you can see there? How do you solve it? How do you get it? You must use your long division. Your long division will help you to do it. Now look at what I did initially with when you have 200, the example there, down there, 233 divided by 100, and that's even a fine number which you can work very easy. But in this case, when you have 15 over 2, sorry, let me just wipe up this. When you have 15 over 2, you use your long division. 2 is the denominator, so is the divisor here. He's the one dividing. 15 is what you're dividing. The dividend or whatever you're dividing will give you your quotients. Now, 2 into 15, the closest number that will times with 2, or rather when you times 2, the closest number you can get will be 14. And that number that can times with 2 to give you 14 is 7. 7 times 2 will give you 14, as we said earlier on, and this will be 1. 2 into 1, 2 is greater number, cannot work. You put your decimal point and you put your 0. 2 into 10 will give you 5. 5 times 2 is 10. Your remainder is 0, and your quotient is 7.5. Thus, 15 divided by 2 is equal to 7.5. In this case, if you look carefully, we have been able to break 15 over 2 into a decimal number. Let's work with the second example, which is 19 divided by 25. You're given a question in the second case there, 19 divided by 25, and they say usually you use your denominator to divide your numerator, which is 19. Now you use 25 into 19, it will not go because 25 is bigger, so you put your decimal point, add your 0, and then 25 into 190. Let's look for the closest number that can give us 190, or that go close to 190 from 25. Now if you work with 25 times 6, it's not going to work because you're going to have 150, which will give us 40, will be remainder of 740, which is not closer. So when you use 7, let's try 7. You have 5, carry 3, so that is 14 plus 3, 175. 175 will remain 15. So 175 is the closest. 7 is the closest number that can multiply with 25 to give you a figure that is close to 190. So we use 7. 7 times 25 is 175. When you multiply through, you will get 15. 25 into 15 will not go, so you add a 0 here. 25 into 150, as we saw earlier on, will give you 6. 6 times 25 will give you 150. And the answer there, our remainder is 0. Quotient is 0.76. Please pardon me with the answer on your screen. It's just a mistake. So please, the answer is 0.76. You can see that we've used proper fraction to convert to decimal number, and we use improper fraction to also convert to decimal number. Now, these are numbers you can play around with. I have compiled a series of numbers that consist of fine numbers like hundreds, like your 1000s, like your 10, and also a series of ones that have to do with numbers that are not fine numbers. The one you have to work your brain, the way I just worked my brain just now to find it. You may need long division, you may need short division, you may need different means. You might even need the LCM method, some of them, if they are comparative, to find them. Let me get a question for us from our year 2020 past question, to see which we can work on. Now you're given a question, you're asked to convert 12.4865 to 3 decimal places. Now, 3 decimal places here means, I told you previously, in our previous lesson, I told you about the decimal place, how you find it in the place value. Any number that comes after the decimal point is called the decimal number. Prior or before the decimal point is whole number. So our 12 will remain there. You count the next 3 numbers that comes after the decimal point, which is 4, 8, 6. Now this is what we need. We need 486. You cross a line here. Now the next number that comes after the 6, which is the one we don't need, you check if it falls between this range. Now you must know that between 0 to 4, you round down. Between 5 to 9, you round up. So is the number up to 5? Yes, it is. Thus, you round up, and your answer now will become 12.487. Your answer in the question that here is C. Now, let's see one more question before we end for today. You're given a question. Again, this is conversion from decimal to percentage. Now, while I'm going to touch percentage in subsequent class, it's good I touch it a bit now based on this question, and also show you how you can move from decimal to percentage. We make a lot of mistakes to guess when it comes to decimal number or conversion of decimal to percentage. There is no way you can get to percentage without meeting fraction. Fraction is the mediator between, I like to use the analogy of Jesus Christ. Jesus Christ is the mediator between man and God. Fraction is the mediator between you, between decimal number, you using decimal number and you get it to percentage, and vice versa. So if you are using from percentage to decimal, you want to convert from percentage to decimal, you must pass through fraction. You want to convert from decimal to percentage, you must pass through fraction. He must be in the detail. So you're having a question that says, let me clean this. You're having a question that says 0.004 and they say convert to percentage. What you know that percentage is anything over 100. That's just the simplest of term you can use. Per cent, and cent there is 100. So you're using the stage of the cent. Now you're looking at 0.004. Now to get over 100, we move one and we have 0.04 over 10. Now we've gotten over 10. We've gotten 10, fraction. There is not yet up to 100. We are looking for over 100. You must get over 100. You move again and you have 0.4 over 100. Now you've gotten your 100. Thus, 0.4 can be classified as 0.4%. This is your answer. So your answer in that here is A, 0.4. I hope you've enjoyed the class for today. I'll be seeing you in next class. Take care of yourself and have a wonderful day. Bye.